Hi guys, today we're doing simple harmonic motion for 3-net HSC. And the definition of simple harmonic motion is motion where the acceleration of a particle is proportional to its displacement from the center. We call it a fixed point, but it's the center, always directed at the fixed point. Basically, it's just back and forth motion, back and forth. We say the acceleration is equal to minus n squared x if the fixed point is 0, or we say x dot dot equals minus n squared x minus x naught, where the fixed point is at x equals x naught. Okay, so if you take a look at this diagram, it shows you, here's the center of motion, okay? And from this motion we're going back and forth, okay, these endpoints here. So we say this center, or this endpoint is x naught, the center, plus a is the amplitude, okay? And so obviously that's how much away it goes from the center, and similarly to the left of it, it goes a units away. Alright, and how long it takes to go back, or go to one endpoint and then back, is your t. It takes t seconds, that's your time. Okay, we call it your period. And if you look at here, to calculate that period, you've got 2 pi on n, and also now this diagram here, you've got to know what's happening with the particle. You've got to know where it's the quickest and where it's... so things like velocity is max at the center, and acceleration equals 0. Okay, obviously if you differentiate velocity you get acceleration. For velocity to be maximum you need to, it's like finding stat points. Also at the endpoints, velocity equals 0 because it comes to an absolute halt, whereas acceleration is the maximum. Okay, here really acceleration is actually minimum, right? But here I've written the absolute value of acceleration is the max here. Okay, moving on, your x formula can be written in either a cos, that's the same as your amplitude, okay, and that's, or a sine, with your center of motion or center point in there as well. That n is the same n that we use to calculate this. So make sure that you keep that in mind, because if you know these things, it will make all these questions much easier. Okay, so moving on. As I've mentioned before, t is the period of motion, so if they ask for period, you're using this formula here. And moving on, now a handy velocity formula, that's if, it just makes things quicker, okay, and that's if center is at x naught. Otherwise it's just v squared equals n squared a squared minus x squared, and that's if center is at 0. Alright, so hopefully that makes sense to you. If not, try the examples will help you out. Moving along. 5 basic questions. Firstly, we're given the acceleration. So we're given the acceleration formula, and we use this, okay, and integrate it with respect. So integrate that and integrate that, because you should know that the integral of x dot dot is equal to x dot, and the integral, or velocity, integrate acceleration, you get at velocity, or if you integrate velocity you get your displacement. Okay, that's just motion. Alright, so that's the first type, where they ask us to find x as a function of t. Alright, so the second type of question is when we're given v squared in terms of x, and in order to prove that the motion is simple harmonic, we differentiate that with respect to x, the half v squared, because as we saw before, x dot dot equals the derivative of v squared on 2. And show that your acceleration can be put in the form minus n squared x minus x naught if center is at x naught, or x dot dot equals minus n squared x if center is just at 0. Alright, so the third type of question that you might be given is you're given the x formula, either in cos or sine, okay? To prove that the motion is simple harmonic. To prove that the motion is simple harmonic, remember this is the definition, this acceleration formula. So it's either that or that, okay? Depending on where your center of motion is. Remember that's at x naught equals 0. Your center of motion at 0. Otherwise, if your center of motion at some point say 1, then this thing turns into 1. Okay. And then with these questions, we can read off the period. We can read off the period because you're given n here. So you can just grab your n period and you can say, oh, t equals 2 pi on n, whatever that n value was, from there, or from there. Okay, and you can read off the amplitude from here. Here's your amplitude, guys. So you can read that off there as well. Your max speed and acceleration. Okay, so you can read these values off, and working, just look and think. Okay. And fourth type of question, we're given the x formula, or actually we're given it in a combination of two trig functions, that plus that. Then we have to use the auxiliary angle method, or subsidiary angle, or transformations, whatever you want to call it. You know how you get that r equals square root of a squared plus b squared, and you get theta equals inverse tan of, I think, b on a? I think it's b on a. Yeah, b on a or a on b, depending on how it's set up really. But that thing there we use to put it into this form. Okay, and then we can proceed in a similar way to part number 3 as above. The last type of question you'll get is we're not given a formula. Okay, we're just given data. So for example, we're given period, we can work out n. We're given the greatest speed, which we know is at the center of motion, and this will allow us to work out things like amplitude. With these questions, the setting out is very important. Do not bluff. So with these questions, you've got to know your stuff. Don't bullshit, okay? Okay, so we're looking at the simple harmonic examples. Number 1, a piece of cork moves vertically in simple harmonic motion on the surface of the water as waves pass under it. Its velocity is given by blah, where x is the cork's vertical displacement in meters. Alright, now using this, find the cork's acceleration in terms of x. Alright, so remember for part A, you've got x dot dot equals d dx of half v squared. Okay, well v squared on 2 is fine. Equals d dx of, minus x squared plus 7x minus 12 all on 2 equals the derivative of minus x squared on 2 plus 7 on 2x minus 6 equals minus x plus 7 on 2. Okay, and that equals minus, and it is just x take away 7 on 2. Right, so your x dot dot is in that form, right? So that is, well, that's what they want really, okay? Now from here, remember, that is in the form minus n squared x minus x naught. So from that, I can tell you already, we find out that your n equals 1, and your x naught, your center of motion, is at 3.5, 7 on 2. Okay? So that answers our part B. Alright, so rubbing all that out. That answers our part B already. Okay, part B asks, what is the center of motion? So the center of motion, x or x naught, whatever you want, is equal to 7 on 2. and find the period of oscillation. Your time period is 2 pi over n, and we know from here n equals 1, so that equals 2 pi on 1, which equals 2 pi, and what's time in? I think in velocity per meters per second, so 2 pi seconds. Make sure you write the units. That was a very, very easy question. Okay, for example 3, you've got the transformation example where it's given this, okay, in the form of that. That's just a basic year 11 trig. 2 sine 2t actually equals 4 cos 2t plus alpha, which we found was pi on 6. And that's your final answer there. Okay. Alright, so now part B says a particle moves so that its displacement is given by that, which we know is 4 cos 2t plus pi on 6, which is easily, or you can see there, it's our normal standard simple harmonic equation form. Show that the motion is simple harmonic, stating its period and amplitude. Okay, so first of all, we don't really need to do much for the period and amplitude. We can already get the period, time period equals, what is it? 2 pi on n. Where's your n from? Here it is. Remember it was nt plus theta. Okay, and it was a cos. Okay, so you can see there's no number in front of it, so your center of motion is at 0. Your amplitude's 4, so there's that question. Your n is 2, so that equals 2 pi on 2, which equals pi seconds again. Okay, and as I said, your amplitude, you can just read it off there, it's just 4. Okay. But to show that it's simple harmonic, you actually just have to show that, you've got to show that x dot dot is equal to minus n squared x, right? Or x minus x naught if, okay, where x naught is the center. Alright, I keep repeating myself because that's the basis of simple harmonic. If you show that, if you show that, or if you can show that, then that's what you need to do. And that's enough proof that it is SHM. So let's go from where we left off at the x. X equals 4 cos, sorry about this, 2t plus pi on 6. You've got your x dot, differentiating that, you get 8. Differentiate cos, you minus 8 cos 2t plus pi on 6. Okay, crap, that was not it. Sorry, that should have been a sine. And then differentiate that, you get minus 16 cos again 2t plus pi on 6. So from there to there, and from there to there. Alright, which equals minus 4 times 4 cos 2t plus pi on 6. Okay, just doing that for you guys so you can see where I'm coming from. Equals 4 x dot dot. Since x dot dot equals minus n squared x, the motion must be simple harmonic. Simple as that. Cool. Alright, so that was example 3 all done.